Today, we are joined by Rick Dye, our Flow Meter Business Development Manager. With that, I would like to welcome Rick.
Well, thank you, Sharon, and thank you everyone for attending this webinar today, wherever you're at in the world. We have a lot of people on the list, so I'm very excited to be presenting today. We have some new products that we want to talk about. We want to talk about some of the applications, but we're going to be discussing how we're going to measure flow in some of these intrinsic safe applications. Again, my name is Rick Dye, and I've been with Teledyne ISCO now for 36 years, so a lot of time here, but I'm very excited to be presenting today. So let's go ahead and let's step through this, and let's do this. Okay, so first of all, why do people measure flow? So I'd like to start off that by just kind of answering some of those questions. I&I, or inflow and infiltration studies, are very common in the world. In some parts of the international market, they call them flow surveys. Enforcement requirements. So what I'm talking about there would be industrial pre-treatment. So a lot more industrial customers out there needing to measure their flow. Billing or water custody transfer, water rights, as we see water becoming more and more precious, especially in the western part of the United States. This is a very important part. And water's not cheap, so there's a lot of money that gets moved around from place to place to pay for this water. Again, different cities are discharging to different treatment works throughout their municipality, so they have to pay for that water being treated. Some examples of this very common: Atlanta, Phoenix, Arizona, Milwaukee, Boston, Denver, and the list goes on and on. So what would be classified a intrinsic safe location? A hazardous rating for any sewer manhole is under what's called the NFPA 820 guidelines, and technically every manhole is rated is a Class I Division I rated manhole. Okay, so when you look at that class, and I'm going to go through this in more detail, but Class I Division II does not meet that rating. So that's another thing to keep in mind. Just because you're kind of intrinsic safe doesn't necessarily mean you meet that rating and fall under the guidelines. We're also seeing a lot more in the industry where consultants are more likely to specify a Class I Division I product. And the main reason is, why take a chance? The cost difference between a intrinsic safe product and non-intrinsic safe is really not that much difference. So people are just more inclined to not take a chance and just play it safe, do it the right way. We also have approvals for what's called ATEX Category 1G Zone 0, and that's more international, Europe. But we also have the IE-CEX rating, international, and that's primarily like Australia. Okay, so let's look at some of the current cities that are requiring this intrinsic safe products. Canada is one that's big, primarily in the collection system as well as wastewater plants. We see internationally, Australia, Singapore, the UK, Germany, etc. Massachusetts, the MWRA is another one. New York City, DEP, Phoenix, Arizona, Milwaukee, Seattle, and really the list just keeps growing and growing. So as different manufacturers out there, including us, develop new products to meet this demand, you'll find more and more products are rated intrinsic safe Class I Division I. Okay, so let's look at some of the different classifications for hazardous locations. And quite often we'll get asked, is this unit explosion proof? Is it intrinsic safe? So to really kind of differentiate between the two, intrinsic safe is more, we're limiting the power in the electronics so that we cannot have enough energy to generate a spark in that area. But this is all taken into account during the design. So the electrical engineers that design products like that have to keep that in mind. So that's what we do primarily with our stuff. Some of the older things that we've done in the past, we had explosion-proof equipment you'll see out there. Sometimes looks like kind of a submarine, or a pretty rugged type enclosure. And what the purpose of that is that any type of explosion or flame inside the housing of that equipment will be contained in that. So explosion proof is containing the blast. Intrinsic safe is limiting the amount of power going into that area. But again, both have to be taken into account during the design phase. But we're looking more mechanical and not electronics on the explosion proof. Today's discussion, we're going to be talking about intrinsic safe. So here's a pretty good drawing or a diagram that I think helps explain it a whole lot better. So if you look at what is a Class I Division I environment, also it has the zone system. Zone would be more international. In the US, we look at Class I, Div I and Div II. So when we look at Division II, that would be an abnormality. So maybe something happened that caused this spill of a hazardous material that could cause an explosion, and that would be under a Class I Division II rating. But most of what we're dealing with a lot of times would be in a continuous thing, such as a sanitary sewer, headworks to a treatment plant, things like that, where we know that they're always going to be involved with some type of hazardous chemical or gas in that environment. So there's a lot of good information on the internet. If you wanted to really dive into this and dig into exactly what it is, you can go there. So, but for this purpose of this demonstration or this presentation is just to kind of give you an idea of what you're looking at. So, but also intermittent periodically, are we going to have something that might come down that line that could cause an explosion? Okay, so another kind of give you an idea, some photos here that kind of spell it out. Continuous, the one on the left would be a wastewater treatment plant. So we know there's always going to be stuff there that could cause that, that explosion. Intermittent applications such as maybe stormwater or things like that, where they don't have a lot of water or any water until they have an event. So you might have a chemical plant, for example, that might have barrels of stuff that are being stored, and maybe when it rains, some of that stuff washes out and can get into the receiving waters. And then, like we've been seeing lately on the news, especially in Ohio, an abnormal one would be such as a train derailment. And we don't want to see that, but that is another way for hazardous material to get into the collection system or the receiving waters. Okay, so let's look at, this is a good little kind of a block diagram to give you an idea of what we're talking about and really what's required. This is common with us, but everybody else in the industry that makes products like this. So this is a pretty generic one, but the hazardous area, obviously in this picture, is going to be in the manhole environment. In this case, they have a sensor on a ring that, which is very common, and that's an area velocity type sensor. But there is a reference to atmospheric pressure that is also in that environment. So there's different things that you have to follow when you go and set up something for an intrinsic safe application. The safe environment, which is outside the manhole, is where you would have your equipment, your whatever flow meter you might be using, and you will always have some sort of a barrier with this design. So the barrier system is kind of, think of it as just a kind of advanced fuse system that's going to limit the amount of power that's going to be able to be transmitted down into that hazardous area. So we have some really good drawings. If you get into something like that and you need some guidance or a little bit of assistance on laying some of this out, feel free to get a hold of us and we'd be happy to step you through what is going to be required. Okay, so let's look at some more environments where you might see something like this. The standard, the Class I Div I, is typically going to apply to pretty much all of the ones I'm going to list, which would be collection systems or sewers, so your normal sanitary sewers, combined sewers. So combined sewer, for those of you that may not be familiar with that, would be where you have sanitary sewer, but will be combined with stormwater. So when it rains, now the sanitary and storm systems are in one common area, and that would typically be a rated location as well. Storm sewers are another one that's kind of on the fence. Some people require it, some don't. And a lot of what you'll see out there is what your risk assessment is. So whoever decides, hey, do we think this is rated or a rated area or not? So a lot of your own risk management people will have to determine that. And that's why it's so sporadic throughout, especially the US, because some places require it, some don't. Some say if it's temporary monitoring, you don't have to. Some say if it's permanent, you do. So a lot of different things, but that's really up to the municipality and the risk management folks. Pump stations are another big one. You see a lot of pumps out there that are typically always going to be rated for a hazardous location because you obviously have a lot of bad gas and fumes and things like that that could cause some sort of an explosion. Wastewater treatment plants, another big one. Pretty much every headwork or the influent to that wastewater plant will be rated Class I Div I. Sludge handling facilities, some nasty stuff there. You're going to want some rated products in that. Chemical handling facilities, another big one for industrial customers. And then again, the treatment facilities, the different types of treatment. You might have your own little wastewater treatment plant on a in the case of like some places international might have a zone or a leather zone or a chemical zone and things like that. So they will have their own treatment facility located on that. IS environments, intrinsic safe environments, pretty much everywhere. Like this picture because it gives you a good idea of just really how complex the systems are out there and where the world is going. But they are all over the world. Okay, I'm going to talk now in the technology side of this. So tried to give you an overview of what the intrinsic safe ratings are, what they mean, the classifications, but now I'm going to go into the flow measurement technologies. The photos I'm going to show you are ISCO products, but I will make reference to other manufacturer stuff out there too, so to kind of give you an idea of how these all work. And there's a lot of similarities between those. Our products are developed at the ISCO Flow Lab. So this, if you ever get to Lincoln, Nebraska, we'd love to give you the grand tour and you can see the ISCO Flow Lab. We do, again, a lot of design work on this. We test all of our flow meter products to see, you know, how accurate they are. Can we improve the quality of the readings? A lot of the diagnostics and things like that. Okay, so one of the other areas that you're going to see, I think the industry going, and we're certainly headed that way as well, would be with smart sensor technologies. So all of the sensors that we produce now going forward will be what we call smart design. So they have the microprocessor and the data is processed in that sensor. These are also going to always be going forward rated Class I Division I. So all of the products we will come out with, and I would expect most of the other manufacturers in the industry would be following the similar suit because we do not see the ratings going away, especially as more and more accidents happen throughout the world. So I'm going to go through some of these. I'm not going to get into great detail, but I do want to explain how some of these work and just so you have a good understanding of that. So if we look at a collection system, here's a pretty good picture of a normal, typical manhole environment. The bottom is the invert of that pipe. So we're taking basically a pipe, cutting it in half, and that is where the water goes. In the case of Teledyne ISCO, we have a variety of different products to fit that. And we have a 2100 series system, which would be 2150s. We have hundreds, thousands of those throughout the world. And some of you might be familiar with those. Tracker would be another one of our latest offerings. And that one we're very excited about. That this was released this year, actually late last year. So a lot of good stuff there. And then the signature meter, which has been out for a number of years, and I'll kind of explain what those are designed to do as well. Okay, not going to get into great detail on Flowlink Cipher, but as we start collecting data in the manhole environment, getting that data is becoming ever more important. People want data. That's really what they're paying for. They don't pay for a flow meter. They want the data from the flow meter. And the best way to get that data currently would be some sort of cellular modem system that would transmit the data to the web to a cloud-based software. In our case, it is what we call Flowlink Cipher. And be happy to, again, go into much, much greater detail if you're interested in something like that. But what this particular graph is showing us would be more of like an eye and eye. So the bars on the top are the rainfall, information, rainfall data, and the line at the bottom would be the corresponding flow rate. So you can see they definitely have some inflow and infiltration problems at this particular location. But web-based, cloud-based stuff is very popular. A lot of different programs out there besides Flowlink Cipher that you can look at, and it really makes it safe and easy to get data and have access to your data without actually having to even have software loaded on your computer. Okay, so let's talk about some of the equipment options for EX applications. So first of all, you have to determine, do you have AC or DC power? What are we working with there? But our particular meter choices would be a couple different ones. The one on the bottom would be the signature, and the signature will have an external barrier, and I'll show you a picture of one of those here in a minute. So the signature would be the electronics, the barrier is the isolation to that environment. 2160, which is one of the older style 2100 series platform, can also be located or used in a intrinsic safe application. But the one thing you need to keep in mind on any of these is with anybody's equipment is sometimes the sensor is rated intrinsic safe, but the meter may not be. So if the meter is not rated intrinsic safe, you have to have it out of the environment, the hazardous location. The barrier will isolate it from the hazardous location. So in our case, the signature with the barrier would be out of the hazard area. Same thing with the 2160. But the DuraTracker EX, the black box unit you see there, has a built-in barrier right inside it. So that can now be located in the manhole environment or the hazardous location. So any equipment you look at, you want to make sure you understand what that equipment is rated and how it's going to be able to be set up in your environment. So real quick, just to kind of give you a little understanding of where some of our stuff is going. The signature flow meter is what we call smart device. And so all the sensors now that we have are pretty much plug and play. You plug one into whatever electronics you choose. Maybe it's the DuraTracker or it's the signature. You plug it in and now you're able to say, oh, you're a laser. Oh, you're an ultrasonic. I'm going to use you with the flume. So very, very flexible. And again, going forward, I would expect most manufacturers to be doing a lot more smart sensor designs like this. A lot of capabilities on this, so we can pick and choose what other options we want. A lot of times people may even want to use this platform to move data, so they would hook up a, let's say, magnetic flow meter that might have an analog output or a Modbus output, sends it to the meter, it stores it, and can transmit it via the internet to the web-based stuff. It can also send it analog output to your SCADA system as well. So a lot of capabilities with this design. Okay, so here's a really nice picture. You'll see there is an army of signature meters on that wall right there. They are all intrinsic safe. The meter is not intrinsic safe, but it's out of the hazardous location. And you'll notice right below it, those boxes are the barriers for each one of those sensors. So they have a really nice, very organized, well put together setup here in this location. Okay, let's go ahead now and take a look at the two different styles of DuraTrackers that we have. The DuraTracker in the blue case is the non-IS version. So that's the standard one. The one in the black case is the DuraTracker EX. And one thing that you will note on this, the connections on the black unit or the EX unit are keyed so that you cannot connect a unrated sensor to the DuraTracker EX. Only the EX sensors will connect to the DuraTracker EX. Okay, so let's look at this. So in this case right here, the keyed sensor, so we can't take a non-rated sensor and plug it into the EX DuraTracker. So that's how you can tell what it is. One of the other really, really nice things that we developed and is coming down the road, again, you'll see it more and more in the industry, would be the ability to have an intrinsic safe modem option. So that's huge. Very, very few people in the world have that capability. And it took a lot to get that approved, but we were able to do that. So now that electronics is in the manhole, the sensors in the manhole, and now you have a modem to send that data out of that manhole with still complying with the Class I Division I requirement. Low voltage operation. So another big one, and we get asked this a lot, is, okay, if I go intrinsic safe, are you limiting the power to my sensors? They're going to affect the accuracy. Is it going to affect the range of that sensor? And the answer is no. It doesn't affect the accuracy. It does not affect the limits or the range of that sensor itself. Everything will perform exactly as it would, regardless of which one it is, intrinsic or non. Battery options. So with the intrinsic safe, it's a little trickier to do. And you would typically use a D-cell setup, which we have now holders that go in this. And I'm not going to go through a big DuraTracker presentation today, but the battery holder, now you can have, you'll see those D cells on that little holder down on the left side of the meter. And you can use those, or we have now lithium ion batteries that can be used in the intrinsic safe design. One thing that we also did is we had to make it a little more difficult to change batteries in the manhole. So you need a tool, wrench, socket, whatever, to remove the plate to access that compartment. So if you look at that a little bit closer, what it's got is a little stainless steel piece that's a battery lock, for a lack of a better term. And what we're doing is we want to make it difficult by design to take that out. So you're not going to stick your hand down in there and change the batteries in the hole, but you simply have to lift it out of the manhole and then change that. So again, don't want to be changing batteries. I've seen places where people might use motorcycle batteries or things like that, or maybe you have alligator clips or deep cycle batteries with alligator clips, and that's not probably a great idea if you are in a hazardous location. And once again, the D-cell and lithium batteries. All right, so let's look real quick at the modem. So again, this is what the modem looks like. More and more people are using cellular modems in their equipment, including us. And what the key here is to be able to update your modem as things change. And we see that happening all the time with cellular service changing. Now it's very easy to get at it. A couple screws, pulls the modem out, and away you go. So when you look at equipment, you want to make sure that you're able to upgrade or modify your system as your needs change. So this is the big one, I think, on the DuraTracker modem. Here's a good picture of just an antenna. This is one of the styles. There are multiple ones out there. There are what's called the blade antenna, which is a flat one that glues to the manhole lid. There are different ones that a lot of people will core a hole right next to the manhole in the street, and they just put a little asphalt on top of it or epoxy and seal it down into that. And there's a lot of times where you can use that antenna in the manhole and it'll still get out. Not always, but there are a lot of people that are doing that. So it's kind of a trial and error situation to see what is going to work, where you're at, and what part of the world. Okay, so now I'm going to talk about the ultrasonic sensor. In our case, it's called the 310EX. It is intrinsic safe, Class I Division I. This sensor does really one thing, measures level. And you'll see there are a bazillion different ultrasonic sensors in the world. And all of us do something very similar. We transmit a sound wave, we hit the surface of the water, it comes back, and we know how long it took for that signal to hit the water and come back. So it's just timing how long it took for that signal to go down and come back. And it's just doing a level measurement. But these are used almost, well, not exclusively, but very common use with primary devices. Primary device would be a flume or a weir. And so now I'm doing a level measurement. I know the dimensions of my flume or my weir. I know it's a 90-degree V or whatever it is. And it does level and converts it to a flow based on those measurements. But we see now more and more overflow level measurement and a CSO, again, a combined sewer. A lot of times they just want to know when it overflowed. So you might have a basic ultrasonic sensor monitoring that. And when you have an overflow, you might want an alarm so that you could send field crews out to investigate what happened and time how long you had the overflow. And in most cases, you can just estimate the amount of flow that went over based on time. And also tank level measurement and things like that. So just your basic level sensor. Okay, so let's look at, again, these are just a couple examples of some of the older style flow meters that you might have seen out there. But the picture on the right would be, a normal flume in a manhole application. But again, these are Class I Division I locations. We're going to talk now about an area velocity sensor. And in this case, this is our 350EX sensor. So it is intrinsic safe, Class I Division I as well. What we do with our sensor is we do a level calculation using a pressure sensor built into it. And that's going to measure the depth. Once we know the depth and the diameter or the pipe dimensions, we can calculate the cross-sectional area. There are other manufacturers out there, and we can do it as well, that use maybe an ultrasonic as their primary level measurement. We can do ultrasonic for level as well. So you just kind of have to pick and choose what is going to be the best for your application. We use an ultrasonic Doppler sensor, a couple crystals in the nose of that. One's transmitting, the other one's receiving. Again, we're doing, everybody does something very similar. There's typically two crystals in about anybody's continuous wave Doppler sensor that you'll find in the market. Beauty of this design, no need for a primary device. So that's key. So now we don't need a flume or a weir. So more and more people are confident in the accuracy that they're getting with an area velocity flow sensor. And their flumes may be underrated now as time goes by, and they can't handle the amount of flow, they surcharge, and so they can't rely on the flume or weir to be accurate. So a lot of people are just tearing the devices out, or are changing them to a larger size and things like that. But now you can do it all without having to even mess with one of those if you don't want to. Most commonly, you'll see these used with I&I, again, inflow and infiltration studies, or as my buddies in Europe would call them, flow surveys. Temporary monitoring, very popular for that, because all you have to do is put it on a ring, put it in the pipe, set the level, and away you go, and you're pretty well done. What they're most concerned with in something like that would be repeatability. So it's not typically for billing when you're doing I&I. This is looking at maybe capacity, or what happens in this part of town when I have an inch of rain in that area. But they want to be repeatable. They want to know again the magnitude of what's happening in there. So what's key is having a non-drift sensor. So whatever design you look at, you want to make sure that thing is stable as possible. Okay, so just kind of a quick picture of what this looks like. Any continuous wave Doppler, again, would do a level measurement. Once it knows what the level is, then it's going to transmit the Doppler signal into the flow, measures the Doppler shift to calculate the velocity of the water. All right, so one thing that we always try to do, and pretty much everybody in the industry does, is make sure they give you the right product for your application. So when you look at equipment, you want to make sure that you get input from the manufacturer and say, this is my application, and what do you suggest? So not everything is going to work. And that's another beauty of smart sensor technology, is that you can have the same meter, but now you're able to mix and match sensors as your demand requires. So for companies that do flow survey or flow services, that is really huge, because now they can have an army of meters, but they can also have an army of different sensors. They pick and choose what they need based on their application. But LaserFlow EX is, again, Class I Division I. You'll notice this one is a black colored sensor. There's a huge label on it called, that has IS on it, so you'll know it's a Laser EX sensor. And this one, the 310 or the ultrasonic to do the level, is located on the back of that sensor itself. It's a little bit more limited just because of the power requirements, but it will do a 3-point scan right in the center of the flow stream, which is typically more than adequate for most applications, and will still meet the 4% rating. So just a real quick overview of laser and how this works. In our case, what we do is we do a level measurement. Once we know where the water is, we know where we want to focus that laser. So we focus the laser below the surface of the water. There are a lot of different manufacturers of non-contact area velocity sensors out there. We're the only ones that currently do a subsurface velocity measurement, but there are a lot of radar surface velocity units out there as well. And for the most part, they do a good job. We went a little different route, and we felt like this was giving us the best quality data. But that's kind of how most of these work. They're above the flow, they're not in the water itself, and able to read the level and the velocity to calculate the flow. With any of these types of designs, the big thing is the signal to noise ratio. So what we're looking at is we transmit a signal, we're getting information back. As time goes on and technology improves, so does the electronics. So the electronics are going to give you now a much, much stronger and cleaner signal compared to the noise. The noise has been reduced. And this will be measured in and stored in a value that in our case we call Doppler power. So when you look at equipment out there, you want to know, first of all, it's rated. Second of all, what information am I going to get? How confident am I in with that data and the numbers I'm getting? So look at diagnostics. That's a big one. This is that 3-point I was telling you about. So there's an ultrasonic sensor, again, measuring the depth. That's a theoretical velocity profile. And in the case of the EX, it's going to do a 3-point scan, and we call that a multi-point, multi-depth velocity scan. Okay, so real quick, the standard area velocity sensors, we get asked that a lot as well. Normally, you're in the 5%, 5 to 10% range, depending on depth of water. A standard area velocity, as the water depth goes up, and I'm talking the tune of maybe a couple feet and higher, they will tend to underestimate velocity, and that's pretty much consistent throughout the industry because they're looking more towards the bottom. So the laser and the other non-contact surface velocity units out there are going to be reading closer to the surface, so they are going to get the peak velocity, which typically follows right below the surface of that water. So in our case, we have what's called MCERTs, Class II. And our specification currently is 4%. So an MCERT is a European thing, primarily the UK. And there's a lot of third-party test results that we have. So we have tons and tons of supporting data for pretty much all the products that we have. But this one of them was the ITRC out in Cal Poly San Luis Obispo. They found that the laser in the test that they ran was 1.8%. The Alden lab one was about 2.7. That's a very well-respected lab on the East Coast. So some of the applications that you would see out there, this is just kind of give you an idea how these things might be mounted. And most of you have seen probably as many manholes or more than I have. But we kind of look at some of these in collection systems and we determine, okay, what is a large pipe, what's small? We kind of defined it as anything above 36 is pretty large. Anything below that would be more in the small pipe range. So you have to determine, will that sensor fit? Can I get a reading in an 8-inch pipe with, a 1/2 inch of level? Maybe that's where you do a non-contact, or is it too big of a pipe and, I don't want to, or maybe it's just good enough. I can use a standard area velocity sensor in that location. Industrial monitoring. This is another one we see a lot more of these types of applications, which are ideal. In this case, all they did was took a pipe coming through a manhole and just cut an opening in the top, about 4 inches wide and probably about 1 foot long. And the beauty of that is now they have very, very good hydraulics through there. No pipe joints, no manhole inverts and things like that to measure. When these things go underwater, how do we do it? Well, standard area velocity is underwater, so it's doing it all the time. When you get into non-contact, and I'm just at this point going to talk about ours, but there are different ones out there that do a similar thing. When the unit goes underwater, it's not going to read, in our case, the laser velocity. So we have another sensor that's mounted on the bottom. What that's going to do is that's going to measure the depth using a pressure sensor, and it's going to use a continuous wave Doppler to transmit out the nose to measure the velocity of the water. So the beauty of these is they're typically mounted at the crown of the pipe. So once that water level submerges that sensor, then it's going to seamlessly transition to that other sensor in there. So there are other ones out there that use electromagnetic. We use continuous wave, but most use some sort of a pressure sensor to be able to calculate the total submergence. So if I'm in a 54-inch pipe, you would tell that level you're 54. As it goes all the way up, it says I'm 55 all the way up to whatever it is. Now you have a very accurate measurement of the submergence in that manhole. So here's a couple that were just recently installed. So more and more redundant systems out there. In this case, they decided they wanted to go non-contact. They chose the laser EXs. And so they have one right in front of the other one. And the picture on the right would show you kind of how clean and neat this setup is. They have the electronics, one mounted right above the other, and backup batteries. But then you'll notice where I have it circled, that's where the intrinsic safe barriers are. So this would be one of your more typical installations with anybody's intrinsic safe application. Okay, so dueling lasers. In this case, there was a test that was ran where we had two in line with each other just to kind of see how well they tracked, to make sure we didn't lose any accuracy. And you can see the top pane is level, they are mirror image. Second one is the velocity, third one is the flow rate. So very, very close all the way through the ranges of those design. Okay, so let's go ahead and I think we'll wrap it up and open it up for questions here in a few minutes. But really, the world's changing. We all see it. And we're seeing the need for equipment rated for the environment and the application. So you need to be careful looking at what you need out there. And, you know, maybe some cases you may determine that it's not a high enough risk. But to follow the letter of the law, then you need to, again, make sure you certify that or verify that you have the proper equipment in that application. Multiple sensors, and again, smart sensor technologies are going to give you a great way to measure flow in just about any open channel application. So now you have the most flexible systems that are available in the market. The electronics are key as well. So now something that's mix and match, plug and play. You might have permanent meters and portable meters. Well, when you have the smart sensors and going forward with, let's say, DuraTracker and Signature, now you can have one set of sensors that are interfaceable between both different electronic designs. Cellular, can't say enough about that. Cellular costs have come way down and much more effective way of transmitting data to cloud-based software. Again, in our example, it's Flowlink Cipher, but there are many other ones out there. So basically, why not just play it safe and insist that the meter meets the intrinsic safe rating or the Class I Div I rating? So a lot of people now just don't want to take a chance and want to make sure they do it right the first time. The beauty of it is that now you can get very accurate data with minimal or no risk and a very minimal upfront cost. So it's not a whole lot more money. Now you have peace of mind, and you know you're going to be safe in that environment and not cause explosion or health risk to anybody. And with that, I'm going to open it up for questions. And again, would like to thank everyone for attending wherever you are in the world. My name again is Rick Dye, so you could text me or you could email me at rick.dey@teledyne.com if I can ever be of help to you. So with that, we'll go ahead and open up for questions.
All right. So we have one question here. Are all the sensors you supply with these products rated Class I Division I? And the answer is yes. Everything going down the road will most likely be Class I Division I, with the exception of we have the standard laser that is not an EX laser that's will probably be continued on just because a lot of times they don't need that rating. But all the other stuff, the ultrasonics and the area velocity, will be Class I Division I. Okay. Another one. How many sensors can I connect to a DuraTracker? Good question. The blue box unit or the non-EX, you can connect 4 sensors. You could have 1 laser and 3 of the other sensors. With the black box unit or the EX unit, we're currently limited to 2 sensors on that. So you could have 1 ultrasonic and maybe 1 350 area velocity on that and meet that rating. Okay, let's see. How do the submersible handle scale buildup and other elements which may change with pipes or the size of the pipe? I think you're talking about maybe silting and stuff like that that could build up on an area velocity sensor in that in the pipe. What we do, and I think a lot of other manufacturers probably do would be measure the signal strength of the velocity sensor. So when you first install one, it's going to be as good as it gets, as clean as it probably will ever be. When they start getting buildup on it, or if you had enough stuff on it, you will see a degradation of that velocity signal, and you will note that in the data storage. So you want to look for a meter that has the ability to log that signal strength, and maybe stuff like what's called velocity spectrum, how good of the velocity reading we're getting, and those kind of things. But if you do have something that's changing the size of the pipe, let's say silt, and we see that often as well. My silt level changes all the time. Unfortunately, there's no magic on that. We can't detect silt level, nor can anybody else that I know of. So you might have to do a manual measurement and go, okay, I have 1 inch of silt this time, and I have 3 inches the next time I went out there, and then you can enter that in the software and correct for that silt level calculation. So no magic on that. One thing I will say is if you use a non-contact sensor, the nice thing is it looks like the silt level will kind of equalize out over time. So you don't see as much of a buildup or change. But if you do have a storm event that flushes the silt out, there's nothing that I know of that will calculate that or tell you, hey, I have no silt now. So a good question, a challenging one as well. Let's see. Okay, do you have recommendations for installation into an underground system of a velocity area sensor without confined space, trained personnel? We have, there are, and other people have as well, street level installation tools. So you can put a sensor on a ring and you can lower it down in the pipe, and then you pull a strap, it collapses the ring, you put it in the pipe. And so what you would do to calibrate that would be set the level at 0. That area velocity sensor is mounted right at the bottom. So when you set it at 0, put it down in the pipe, you should be pretty close to being calibrated. Having said that, it's not an easy thing to do. You're probably limited to roughly 20 feet, depending on, again, the pipe size. We go up to 15 inch. When you get into larger than 15, then you need some sort of a scissor ring assembly, which would require confined space entry. But once you do that first install, if you did it with the street level poles, you could pull the strap, pull it out, clean it, and put it back in. In the case of the laser, you would require a confined space entry initially to bolt the bracket on. Once you bolt that bracket in place and get everything installed, the next time you had to do anything, remove it, clean it, or whatever, you can go with the street level tool and actually just one little twist of the pole, and it'll unsnap that laser from the bracket. You lift it out, you do cleaning of the manhole, vac trucks, whatever you're doing, and you clean out the sensor, you put it back in and lock it in place. So there are some ways of doing it, again, depending on how deep that manhole is. As a general rule, from everything I've seen, when you get below about 20 feet deep, you're probably going to have to go in there. Okay, here's one. Is a flow sensor paired to a meter? In the old days, if you, whatever meter you bought, a lot of times it would have to go or be calibrated with that electronics. That's gone away, and that's been gone for quite a while. So all the sensors now, especially the smart sensor design, you plug it in, you scan for it, it sees what it is, and it doesn't care, what serial number it is. It will calibrate just fine and read accordingly. So no problem with that. Another question on here that I'll probably have to defer to somebody else, but the question is, does a 350EX put out a Modbus register of flow, or does it require a controller? We do have a Modbus register output on all of our equipment. And I know it's going to have level velocity. I'm not 100% sure on flow. So what I would like to do is get back to you on that. I have your name, so we will find out the answer to that, and we will also respond to everybody else. So everybody on the on this meeting invite can see the answer to that. Okay, analog output. Here's another one. If I want an analog output, what do I need to do? Well, analog output, especially you're going to a SCADA system, most of the time that electronics would be out of the environment. So it would be like that one picture that I showed with all the meters on the wall. In that case, you would have an analog output there that would go to your SCADA system. But the analog output we would offer would currently be with the signature flow meter, and the DuraTracker does not offer that currently. But signature is going to be out of the environment, and that's the way you would do it. And that seems to work just fine. So, and with that, I don't believe I have any more questions. But if you do have any additional questions after you've listened to this or watched the video again down the road, feel free to reach out and contact me. Again, it's rick.d as in dog, EY, at teledyne.com, TELEDYNE.com. And be happy to help you, as well as our local reps and sales professionals all over the world. Let's see. Oh, one more just popped up. Let's go ahead and get that one. Because wastewater is subject to foreign objects and piping systems, some of which are large. How do the sensors handle localized turbulence? Great question. So when we install one, what you're going to see is, let's say I have a clean pipe, no debris in it. It's going to transmit that velocity signal. This is one that's in pipe. Transmit the velocity signal out the nose. It's going to measure a couple things: the signal strength, so it tells you there's plenty of stuff in the water, and it will also tell you if it's covered in something. Velocity spectrum is a little different, and what that's going to tell you is more how bad my hydraulics are. So if I have a good hydraulic condition, water's flowing straight at it, you might have a spectrum strength of 70. If I have a chunk of concrete that comes down the line or a big rock, that would disrupt the velocity profile. Then your turbulence and everything else, you would see that in that velocity spectrum information. So you can alarm off of those things. You could say, hey, normally this should be greater than 60. If it gets to 30, something's going on. Send me a text message, email or something, so I can get people out there and get that taken care of. The other obvious way of minimizing this effect would be with the non-contact sensor approach. And I think with that, Sharon, I think we'll probably go ahead and wrap it up. I want to thank everyone again for taking time out of your busy schedule and attending this webinar. We'll be having, again, more and more down the road, and hopefully you can find time to attend those as well. But thank you very much. Stay safe and be careful out there in the sewer world. But thank you.